In this video, we will perform a small code refactoring, and the reason for this is that using the scene view to get the view matrix and projection matrix only works when you have an editor attached. This means that when you package the build for shipping, that on startup it will hit an error pointing to that the scene view cannot be retrieved or something. Like so. So to solve this, we have to come up with our own method to create the necessary matrices. And I will cut this video short by pasting most of the code, as it is pretty straightforward and I think it does not need a lot of explanations. And as a starting point, I will grab the latest code from the master branch and I will add it, and then at the end of the video I will push it to master as well, so that you don't even have to sit through this entire video, but if you just need the code, you can go to GitHub, you can copy it, and that's about it. And if you just randomly stumbled upon this video, feel free to skip it, as it won't be relevant to you, I assume. We will start by defining our data first. So it will be a struct, we call it f matrices, and we will need to return 5 matrices. The view matrix, the inverse view matrix, the projection matrix, the inverse projection matrix, and the inverse view projection matrix. We could just return these two and then derive them ourselves, but I think this will be more convenient, just returning all the matrices we need and then deciding which ones to use and which we don't need. And last, we also will need the near clipping plane distance. And that should be it. So next we will define the method. It will return the data struct we just defined. We will call it get matrices, sure. And it will need a uworld reference, and it can be const. And now we will need to implement it here. Okay, so let us first define the returned value. We call it just matrices. Alright, so I will start by pasting in some code I found online. So this bit over here is responsible for getting the view matrix, and essentially what it does is it gets the current location of the player and the rotation and uses it to create a view matrix. So it takes in the inverse location and inverse rotation, and it creates a view matrix out of this. And this next bit of code is responsible for creating the projection matrix. So it gets the x, the y, the size. It builds a minimal view info, and it generates the projection matrix. So after this is done, what we need to do is we need to wire up the data to our struct over here. So we can just say view matrix equals to view matrix. Matrices inverse view matrix equals to view matrix dot inverse projection matrix is the projection data projection matrix, like so. The inverse projection matrix is this one. We will set next the near clipping plane distance, which we can grab from the projection matrix, like that. Okay, and last we will need to create the inverse view projection matrix. I will do it by taking the inverse projection matrix and we multiply it with the inverse view matrix, like so. And this should be it. Let me just quickly rearrange it, like so. And now we will need to replace our scene view calls to using our data we just created. So first we can make this const again. And this is the thing which I mentioned, so we won't be needing this. We can just outright delete it, and we can say we want to have the f matrices here. And we want to get the matrices. We want to call get world, and we will need to dereference it. And here we will say we will need the matrices, the near clipping plane distance. This can be const as well. Alright, and down here we will need to replace some things. So we say matrices.viewMatrix. And these two we don't need. We will just replace it by matrices inverse view projection matrix. We compile. Okay, we hit play and seemingly nothing has changed. It still all works fine. We can extend it and it looks very good. So now we can package the game and then we can run it. So we choose package. We compile it. Okay, so now if we run the executable, it doesn't crash, it works. If we reduce the resolution, it still is like it should have been. Alright, and that's it. Yes, and I wasn't really sure if I should have made this video, but I kind of feel obligated to do this because in the first video I told you that you should use the scene view to get the view matrix and projection matrix. So I kind of felt bad leading you in the wrong direction without giving you a proper solution. And yes, now I consider that I'm done with it, and the next video in this series will be most likely how to solve the ugly shadows which we have right now. So if we take a look here, the shadows are messed up. So this is something I will be solving whenever I get my hands to it. And when I have a solution, I will update the series and I will attach a new video to it. And yes, yeah, that's about it. Yeah, thanks for watching, and see you in the next one. Bye.